This lesson is about limits and continuity, and we're taking the approach using graphs. The definition of limit of a function is the function f has the limit L as x approaches a, written as, this is the notation, lim for limit, and then x goes to a of f of x is equal to L if the value of f of x can be made as close to the number L as we please by taking x sufficiently close to but not equal to a. So it's like as we get closer and closer to a value for x, a, not including that for x, that would be a. The y values of the graph are going to get closer and closer to a certain number, and that would be L. So this definition is very informal. I would recommend getting the formal definition, which is very complicated, if you're going to take mathematical analysis course. Let's go to the next one. Let's do an example. So what is limit of f of x as x approaches 2 here? So as we're approaching 2, it's right, 2 is right here. The piece of the function that is red, it's just, if you just walk with, if you are taking values that are coming from the left side of 2 and getting closer and closer. So you're walking on the path of the function from the left side of the 2. You're arriving at this point at x equal to 2. And that's the limit of the function as x is approaching 2. What is that? That's the value, y value, f of x equal to 2, equal to 1. And that's what we're showing in here. So in one side it's true. Let's make sure that it's actually correct on both sides, because any value as we approach, any y value as we approach x equal to 2 should be approaching y equal to 2. See, those points that we made on the graph also approach 1. The y value of those points also approaches 1. So as x values approach 2, y values approach 1. Limit as x goes to 2 is the limit of y values that are approaching 1. Now, what about limit as x is approaching 3 of f of x? What do we have any y values approaching a certain number also or not? Look at this. The path that comes from the right side, see, function has two paths on the right side or left side of the 3. The path that comes from the right side of the 3 is actually approaching this value 1. But the path that comes from the left side of 3 is just going to an infinity, like that. So not from both sides as we're approaching 3, we're getting a same number. And that means that we don't have a limit. But all this discussion about limit as we are approaching from right, approaching from left, that actually leaves us with another definition for limit, which is limit from left and limit from right. And so that comes next. So what else do we want to say? So here, as we were getting closer and closer to 3, using this path, we could predict the value a value for x equal to 3, for a y value for x equal to 3. From this side, we could not predict a y value from the x equal to for the x equal to 3. And the other way around, if I was approaching x equal to 2 on a blue line, I could predict a value for y value for x equal to 2. When I was approaching from on the red piece of the graph, as I was approaching x equal to 2, I could predict a value for y equal to for y value for x equal to 2. So that's the basic of the limits. If you could predict a value for an x through points around x, so the values of the points around x give you a prediction. See, this one wasn't giving a prediction, it was just going to infinity. This set was giving prediction. But for 3, I needed both sides to give prediction and one side wasn't. For 2, I needed both sides to give prediction and both sides were giving prediction. And the prediction was the same. So this is the concept of limits. So if you can get prediction from both sides, you will have a limit. That's the basic graphical approach to limit. So all these discussions of approaching from left, approaching from right, how do we make a notation out of this? This is limit of f of x as x approaches a from left, that we show it with that negative sign on top. This is the limit as x approaches a from right. We show it with that positive on top of a. And so this one means as we decrease values of x to get closer and closer to a, if we're predicting a value for y, and then here it says as we increase values of x to be closer and closer to a, do we predict anything for y? A y plus, y minus, plus means where the x values are more than a, minus means x values are less than a. That's from the left. This one is from right. And so this is also the definition. And so as we get closer and closer to a from either side. So there's this theorem, nice theorem, that when we were explaining the example, we actually kind of used. It says limit of f of x is equal to L if and only if the limit of f of x from right is the same thing as limit of f of x from the left. And this implicitly tells you that both limit exist and they are equal. When you're writing it this way, they both exist and they are equal. So if the limit from right and left exist and they are equal, then the limit exists. And if the limit exists, then both limits exist and they are equal. Both limits from left and right exist and they are equal. That means that's the if and only if part of it. Means if this is true, these two are true, and if these two exist and they are equal, and if these two exist and they are equal, then this one exists, and that's it.